The second part of lesson 28 is functional notation. And that's a new phrase, functional notation. But the concept of functions is not new to us. When we were younger, in our younger years in math, we used to have these things. There was an input and an output box, and you had to sort of figure out the pattern. You look and say, okay, my pattern might be that I'm multiplying it by 2. It might be that I'm adding 2. I'll go to the next one. Here's 6 to 8. Well, it isn't that I'm multiplying by 2, because otherwise this would be 12. So it's not multiplying by 2, but it still is consistent with adding 2. So maybe my pattern is adding 2. Let's look at one more. 20 to 22. Oh, I know what I'm doing. Every time I plug in a number, maybe that number is x, I'm adding 2. So if that's true, and it equals 12, then this original number, since this is my pattern here, is x plus 2, then this must be 2 less than 12, which is 10. 10 plus 2 equals 12. What I just found basically was like a function. This really was a function. And so there's an input, and then there's an output, and the input goes into the function. We figured out what it was. It's x plus 2. And then there's an output. And so it depends on what you put in as to what you're going to get when you spit it out, your output. But the pattern remains the same. The function remains the same. So that really was a function. Today we're dealing with functions, and it's kind of like someone did this to us. They said, well, here's the inputs and outputs, and here's the machine, here's the function. I'm going to give you that. So what is f of 0? If f of x is x plus 7, what is f of 0? So I plug that in. 0 plus 7. If the input were 0, what is f of 0? The output would be 7. If f of x is x plus 7, what is the value of f of 2? What that's really saying is put 2 in for the x. 2 plus 7. The output would be 9. If f of x is x plus 7, what's f of negative 2? Put the value in there. Negative 2 plus 7 would be negative 5. And finally, if f of x is x plus 7, what is f of 4? Well, 4 is the input. Well, 4 plus 7, then the output would be 11. So today, in functional notation, really they're kind of telling us what it's going to be doing. It's going to be, in this case, adding 7. And then saying, well, if that's the case, then they're going to give us the inputs. They'll only give us 1. And then figure out what the output is. So in a way, you're really solving, substituting. And you'll see here, we've really done this before. We just didn't call them functions, and we didn't call this process this functional notation idea. So here's an example, and then we'll see how it relates to what we've done before. If f of x, that's like saying, oh, here's a function. If f of x equals x times the quantity x squared minus 3x, find f of 2. What that's saying really is, here's a function. What is the value if you plug in 2 for all the x's? We've done things like that before. So you plug in 2 for the x's. And now we simplify it. Follow order of operations. Didn't leave myself much room here. If f of x is x times x squared minus 3x, f of 2 is negative 4. We found the solution. What this is like, we've had these problems before. Functional notation is just like this problem. Here we've got evaluate x squared times the quantity 2x minus 1 if x equals negative 2. We've done problems like this before, and we said, okay, plug it in. Negative 2 squared times 2 times negative 2 minus 1. Negative 2 squared is positive 4. 2 times negative 2 is negative 4. Sorry, I got a fly flying around again. 4 times negative 5 equals negative 20. Look at, these are exactly the same. We've done this before. Evaluate this, and this all looked and sounded familiar. It is just like, these two problems are just like one another except for the terminology. In calling it a function, we would say if g of x equals x squared times 2x minus 1, just like up here, find g of negative 2 is exactly like saying evaluate x squared times 2x minus 1 if x is negative 2. All we're going to do is plug in the negative 2 for all of the x's, and we have the exact same problem. Probably don't need to go through it again, but functional notation. Very similar to previous problems. Really, it's the terminology that's different.